Good morning everyone. I am Tanushri Dalai from Civil Engineering branch, and today I am going to teach you your Theory 1 paper which name is Structural Mechanics. So in the last class we discussed about the stress strain curve of mild steel, okay, and here what is the difference between the ductile material and brittle material we discussed. Then in stress strain curve, the variations of the stages of mild steel we studied, correct? So today we will learn about the graphical representation of ductile material versus brittle material. So see, the green line indicate the variations of stress strain diagram of the mild steel, and the blue color line indicate the stress strain graph of the brittle material. Okay, so you can see from the origin to the first red point, that means I told you that this region is known as proportional limit. That means it is obeys the Hooke's law. Hooke's law means it is says that within the elastic limit the stress is directly proportional to strain. So this line is look like a straight line, okay, and the point here, this point is your point A, which I told you and I show you in the previous class also. It is the point indicate that elastic point or elastic limit. Okay, so this point will be occur in the ductile material as well as in brittle material. Okay, and in case of brittle material, beyond the elastic point it start plastic limit. That means from this point to this point. Okay, and after some time the material is filled here. Here in case of brittle material there is no yielding point, there is no ultimate strength point. Directly after the plastic limit up to some point it will fail. But in case of ductile material, as you can see here, it is a mild steel ductile material. So here we can find out the elastic point, then the upper yield point, then here it is indicate a lower yield point. After that it gives a ultimate strength point, which is also known as tensile strength of the material. Then after that it will fall down. Okay, and from the yield point to the tensile strength, this region is known as your strain hardening region, and from the ultimate strength point to the breaking point, this region is known as necking point. Okay, from this point to this point is your strain hardening region, and from this point to this point is your necking point. Okay, this is the difference between brittle and ductile material with a graphical representation. Okay, so now comes to the principal stress and principal strain of a body. So what is it? So generally in bodies are subjected to normal stresses and tangential stresses. Normal stresses are those which act perpendicular to the surface, such as tensile and compressive stresses. You know that whenever a body subjected to Sorry. So now you can see that in case of a body, when it is subjected to a loading system, then you know about the stresses. That means the internal resisting force per unit area. Okay. So in case of normal stresses, in this case we will consider the perpendicular stresses like compressive stress and tensile stress. Perpendicular to which? Perpendicular to the surface of the material or the plane of the material. Okay, so you know that the compressive force or tensile force is a direct force on a material. So due to this loading system, the body will give a stress which is known as your tensile. According to the tensile force, it is known as tensile stress, and according to the compressive force, it is known as compressive stress. So in case of normal stress, we have to consider two load or two stresses, which is your tensile and compressive stress. Okay. Now come to the tangential stress. So what is it? The tangential stress are those which act along the direction of the tangent to a body. Example, shear stress. So in simple way, you have to remember, in case of tangential stress, we have to consider the shear stresses developed in a body due to the external loading system. Okay. Next is, what is principal plane, what is principal stress, and what is principal strain. So basically, the plane which are subjected to only normal stress and has no shear stress are called principal plane. Okay, that means in a body which is subjected to only normal stresses like your compressive stresses or tensile stresses, okay, and there is no shear stresses will act. The shear stress is vanished in that portion or in that plane. Then that plane on which only tensile and compressive types of stresses are acting, that plane is known as your principal planes. Okay. Then the magnitude of the stresses normal to the principal plane is principal stresses. That means on the principal plane, which kind of stresses is developed, its magnitude, that means that value is known as your principal stress. As an example, if there is 20 kilonewton per meter square is the stress value, then your principal stress is 20 kilonewton per meter square. Okay. So you have to remember the magnitude of the stress value. Then due to this principal stress, whatever may be the deformation will form in that body is known as your principal strain. Okay. So strain due to this principal stress is called as principal plane. So this is all about principal plane, principal stress and principal strain. So in any loaded member, there exist three mutually perpendicular planes on which the shear stress vanishes. That means the shear stress is 0. The three planes are called principal plane, and the normal force acting on the principal plane are called principal stress. That means in any kind of plane, if the plane is in 3D modeling or 3-dimensional field, then you can say that here the combination of normal stress and tangential stress will act. The normal stress will act in the 2D axis, that means in case of x-axis and y-axis, and the tangential stress will act along the xy plane. Okay, so in the diagram you can understand very well. So we will discuss rest of the thing in the next class. Thank you.